Hi everyone, my name is Rituja and welcome back to DataToCrunch. In today's video, we are going to build one another end-to-end Azure ETL pipeline. So let's try to have overview about the same. So in this end-to-end Azure Data Engineering Project, we will try to simulate how any company functions and can build a scalable governed data pipeline. So in our case, we will take a data set of Adventure Work Cycle, which is a global bicycle manufacturer and retailer. And for that, we will see how this data pipeline will function. So in this data set, we have operational data such as, for example, products, sales, resellers, and sales targets that will be initially stored in our Azure SQL database. But as we are going to build everything from scratch, it is quite obvious that we won't be having any data into our Azure SQL database. So for that sake, we will see one more additional step in which we will see how we can store our original data into on-premise SQL server, which will be SSMS. And from there, we will see how we can fetch that data from SSMS to Azure SQL Database. So once we will have our data into SQL Database, then we will utilize and implement Azure Data Factory. And with that, we will try to pull our data from Azure SQL to our ADLS Gen2. So after utilizing this ADF to ingest the dataset from Azure SQL to Bronze layer of ADLS Gen2. Afterwards, we will try to utilize Azure Databricks. And in Azure Databricks, we will implement Unity Catalog for our data governance. And after that, we will try to clean our data and transform our data. Afterwards, we will try to enrich our data and then we will store it into our silver and gold layer into ADLS Gen2. So after applying this, finally we will connect our Power BI to our curated gold layer to create the dashboards and reports that deliver actionable insights to the sales performance or regional trends and reseller effectiveness. So now let's try to understand our data first. We are going to simulate a data pipeline using AdventureWorks 2022 dataset, which I have taken from the Kaggle. And this dataset has been modeled after a retailer and manufacturing company, which is AdventureWorks Cycle. So this company basically manages the bicycles, resellers, and the sales team across the region. So for that, we have 7 files on which we are going to work, and these 7 files represent the actual operational data in the business. So these are the 7 files, and we will use these 7 files throughout our pipeline. And each of these files represents a piece of AdventureWorks business operations. So the first one is product. So this details about each bike or the product that company manufactures. Then we have region. So this defines a geographical regions where this company actually operates. Then we have reseller. So this is the third party resellers who sell the AdventureWorks products. Then we have sales. So this is nothing but a transactional sales data of that company. Then we have salesperson. This basically gives us the internal sales staff in this CSV file. Then we have salesperson region. So this gives us the mapping of each salesperson to that specific sales territory. Then we have lastly targets. So this CSV file gives us a monthly or quarterly sales goals. So these are the 7 files which basically forms a core of what you would typically see in any company's operational database. So this is the dataset on which we are going to work. This is how our project flow looks like. So as I have told you earlier, our data is going to be into Azure SQL Server or SQL Database. But as we know that we are going to build everything from scratch. So in the start, at the initial part, we are not going to have anything into SQL Server. So for that sake, we are going to see one more additional step, and that will help us to gain more knowledge about how we can connect our on-premise SQL Server, which is SSMS, to our cloud service Azure SQL Server. So this will be the additional step. So the first, what we will do, we will download our AdventureWorks dataset, and then we will upload that dataset into our on-premise SQL Server. Afterwards, we will see how we can pull that data from SSMS to our Azure SQL Server. So this is on-prem service and this is our cloud service. So after this additional step, we will see how we can pull our data from one cloud service to another cloud service. So in this, our first cloud service will be Azure SQL Server, where our data lies. And then the next second service will be our storage service, which is ADLS Gen2. So we will utilize Azure Data Factory. In that, we will see copy activity and for each activity. So with these activities, we will create one pipeline and we will see how we can pull our data from SQL Server to the bronze layer of ADLS Gen2. So this process will be our data ingestion process. So right now in the bronze layer, we have our raw data. So the next step will be data cleaning and data transformation. So for this, we are going to implement Azure Databricks, and in Azure Databricks, we are going to see or going to implement the object model of Unity Catalog. So in this object model, we will see how we can create a Metastore, then how we can create a credentials, afterwards how we can create three external locations for our three different layers, which are bronze, silver, and gold, which we have created into our ADLS Gen 2. Then we will see how we can create a catalog. In catalog, we will see how we can create schemas. So in this case, we are going to require three different schemas for bronze, silver, and then for the gold. And then in schemas, we will see how we can create tables as per our requirement. So this will be our object model of Unity Catalog, and we will try to implement this object model. And with this model, we will see how we can clean our data and transform our data. So first, after our data cleaning, we will store cleaned data into our files in silver layer or silver folder. Then we will perform that advanced additional step, which will be of data transformation. And this data transformation will help us to curate our data and make our data business ready. So once our data is business ready, so we will store that files or store those files into our gold layer. And lastly, we will see how we can connect our Azure Databricks to the Power BI. And after creation, we'll see how we can create the dashboards and reports to represent our data, cleaned and transformed data in front of the business so that business can take the decisions accordingly. So as we know that we have created tables here, so we will try to fetch those tables, and in that table, we'll try to fetch the data from the gold table or the gold layer, which we have stored already here. And then we will connect this to the Power BI and then we will create these reports. So this is how our in-depth project flow will look like. So now let's try to learn more about management level and the hierarchy. So Azure provides you with the 4 levels of management. So the first one is management group, followed by the subscription. Then the third one would be resource group, and the last one is the resources. So if we talk about the management group, so it basically helps you to manage the access, policy, or the compliances for the multiple subscriptions. So all the subscriptions in that particular management group, it automatically inherits the conditions which are applied to that respective management group. So subscription, like what is subscription exactly? So subscription, we can say that it logically associate the user accounts with the resources which they create. So each subscription has limits or the quotes on the amount of resources it can create or use. So organizations can use these subscriptions to manage the costs or the resources which are created by that particular user or the team or the project. So basically in the company, what they do that for any respective team or that particular user, they will allocate one subscription so that whatever user will create across that subscription, that will get billed for that subscription. So it will logically associate that user with the resources which they have created. So this is how this subscription level works. Then the next one is resource group. So if we talk about it, then the resource group we can say that is a logical container where you can deploy and manage the Azure resources like virtual machine, web apps, databases, or the storage accounts. So we can say that it is nothing but a logical folder in which we are going to store all our resources. And resources are nothing but the instance of your services which you can create in that resource group. So in our case, we have these services, right? Which is like ADF or the Databricks. There are Synapse also, which we will use into any another project or SQL database or ADLS or like any virtual machine. So these all are nothing but the resources, which are nothing but the instances of the services which you can create. And we basically what do we store all these services into a particular folder. So that folder is nothing but a resource group. So in this resource group, I can say that I have stored the SQL or the ADLS. So that depends on you. So what we'll do, like we'll have subscription. If you have free account, then you will get that subscription for particular dollars for the free. Or like if you're using pay as you go, then you will create one new subscription. And in that new subscription, then you will create this resource group. And in that resource group, you will create all the resources or instances which we are going to use to create our ETL pipeline. So this is how this management level and hierarchy works. So now we will try to implement this management level and the hierarchy in our ETL pipeline, and we'll see how we can create the subscription, then resource group and the resources, and via that or through that we will create our pipeline. So now let's move ahead and see our practical part. If you are new to Microsoft Azure portal, then it's the best thing to go for get started with Azure and then try this Azure for free. So you will get a period of 1 month, either for 1 month or for $200 USD. You can utilize your Azure services. And if you're not eligible for this free account, then you need to click on pay as you go, and then you need to fill out all the details and need to enter all your credit card details and everything, and then you need to sign in for your Azure portal. So once you will sign in for the Azure portal, this is how our portal looks like. So these are the Azure services which I have recently used. Then the services which I have created, it has given those listings under the recent tab. Here we have all the options of home, dashboard, Cosmos DB, SQL databases, each and everything. If you are not getting anything, just simply search for that particular resources or the services here. So as per the hierarchy, first thing is about the subscriptions, then click on the subscription. So if you are using free Azure service, then you will get your subscription name as maybe Azure subscription 1 or something, and you will get the current cost here. It's good to keep the track of your costing so that you can use different Azure services accordingly. In my case, I have opted for pay as you go, so this is my subscription which I'm going to use for our project. So if you don't have any subscription, then simply click on add. Then you will give your subscription name here, then billing account, billing profile. So basically here you will need to enter your credit card credentials and details so that it will generate invoice on that credit card. And then just click on review plus create. And then your subscription will be ready to use, and you can use that subscription for your project. So in my case, I'm going to keep my existing subscription for the use. And moving ahead, the next thing will be to create the resource group. So I'll click on I'll just search for resource groups. Here, these are the recent resource group which I have used. We are going to opt for the new one. So for that, click on create. Then it will give your particular subscription. If you have multiple subscription, then click on the drop down and select your accurate subscription. Then you need to give your resource group name. So for example, I'll give RG Adventure Walks. So this will be my resource group name. Region, select your nearest region. Click on next. Tags, I don't need to change anything. Click on next. And then click on create. So our resource group is ready. So if you don't see here anything, just click on refresh. Okay, so this is our resource group RG Adventure Walks. And now under this resource group, we are going to create all of our Azure services. So the first one would be storage account. So in this storage account, we are going to create our 3 folders, right? So click on this storage account, click on create. So under the basics, we have our subscription, which is correct. Then this is the resource group, which we have created just now. So maybe in this situation, if you would like to go for a new resource group, then you can create that resource group from here also. Just click on create new, give that new resource group name, and that will get created, and select that respective newly created resource group. As of now, I have just created this RG Adventure Works resource group. I'll opt for the same and we'll move ahead. Then you need to give your storage account name. In our case, maybe it would be ADLS Adventure Project. Then the region, select the nearest region. Under the primary services, our primary service would be ADLS Gen2 because we need to store our data and then we need to access that data. So ADLS Gen2. Then under the performance, we have two performances. One is standard and the another one is premium. Let's try to understand it very briefly. So the standard one, we use it for HDD purpose. On the other hand, premium we use for SDD purpose. So the standard one is basically used for general purpose workloads. On the other hand, premium we use it for low latency apps. For example, it would be maybe databases or anything. And this standard one is preferably cheaper. On the other hand, premium is costly, but along with the cost, it gives faster performance too. So in our case, for the cost optimization, we are going to use the standard purpose one because we don't need any high cost performance here. So I'll opt for the standard one. Then under the redundancy, we have 4 redundancies. Let's try to understand all these 4 redundancies very briefly. Now let's talk about the Azure Storage redundancy offerings. So Azure Storage offers like various redundancy options, basically to ensure that your data remains available and durable, and even in the face of like hardware failures or power outages or any natural disasters, we need our data intact. So for that purpose, Azure offers this redundancy offerings. So these redundancy strategies basically reflects your data across the different locations by providing the protection against your data loss and ensuring that business continuity gets maintained. So this is the main purpose of this redundancy offerings. So the key purposes of this storage redundancy would be like first would be data protection, because redundancy safeguards your data from unexpected events such as, for example, hardware malfunctions or the data center outages. So it basically protects you with these such kind of outages, and it maintains the multiple copies across the various locations. So data protection is the main key feature for this or key purpose for this redundancy offering. Then the next one would be Azure, this high availability. So by replicating this data, this redundancy ensures that your applications can access the data with minimal downtime even during the disruptions. So high availability is the second most important factor. Then the third one we can say is disaster recovery. So in the event of any regional disaster or certain redundancy options, it will basically allow you to get protected from these data failures by storing that data into a secondary region. So basically it facilitates the swift recovery and the continuity of your operations. So selecting this appropriate redundancy option, it depends on your organizational specific needs, balancing factors like cost, or data availability requirements or the disaster recovery objectives. So there are so many things or the factors. Based on that, you need to select these one of like the redundancy offering which is best for your project. So the first option is locally redundant storage. So what happens in LRS? So LRS basically replicates your data 3 times within a single data center. So we have this primary region. So in our case, we have selected East US, right? So that is our primary region. In that primary region, we have data center. And in that data center, we have 3 copies of our data stored within the same data center. So that is how this LRS functions. So basically, this LRS safeguards your data or the activity against the hardware failures within the same data center. So it's good option, but the limitation for this storage would be like it does not protect against the data center wide disaster, like maybe for example fire or the flood. Then if that in that case, if that complete data center gets disrupts, then it is of no use. But it like rarely happens or will never occur. But there is a possibility of that occurrence. So for that purpose, LRS would be beneficial. And if your project has very minimal costing, then also you can opt for this LRS option. Then the second option is zone redundant storage. So what happens in this zone redundant storage is ZRS, it replicates your data across the 3 availability zones within a region. So we have our East US primary region, and in that region we have 3 different availability zones, and in that we have 3 different data center. So in LRS, our copy of our 3 copies were in like one data center, but in ZRS, our 3 copies would be into different data centers, but in a same primary region. So that is how this ZRS functions. So the next one would be geo-redundant storage, which is GRS. So in GRS, this GRS basically combines the LRS within the primary region and asynchronously replicates the data to a secondary region. So we can say that data is synchronously replicated 3 times within a single storage cluster in the primary region, and then it was asynchronously replicated to a secondary pair region. So this is our primary region. So in our case, it's East US. So in that data center, it has replicated your data 3 times synchronously, and like despite of this, it also replicates your data into a secondary region 3 times within the same data center. This is how this GRS function. So basically, we can say that it will protect or it will provide you disaster recovery capabilities in case of any regional outage. So like what would be the limitation for this GRS? Then we can say that failover to the secondary region, it requires manual intervention. So without that, your data will be intact in your primary region. So the fourth one is geo zone redundant storage, which is GZRS. So in this GZRS, basically this GZRS integrates with ZRS within the primary region and asynchronously replicates the data to a secondary region. So our data in our primary region East US, our data is synchronously replicated 3 times within 3 different data centers. These are synchronously replicated, and apart from that, it asynchronously replicates your data 3 times into your secondary region. So this is how this GZRS function. So we can say that it will offer you the enhanced disaster recovery and high availability. But the limitation would be for this would be like failure to a secondary region. Again, it will require manual intervention. Apart from that, your your data is already copied three times into three data centers into a primary region. So this is the I can say that this GZRS provides you the maximum protection to your data from all the disasters and recoveries, but it is not cost efficient. It requires a lot of cost. So it completely requires on your project requirement and the budget, which is like available and which is allowed to use. So this is how these are for redundancy storage services functions. So in our case right now, for the cost optimization, we are going to opt for this LRS option. So I'll select that, click on next. Then here we have another important checkbox, which is this hierarchical namespace. So in this situation, we need to select this enable hierarchical namespace option because we need it we need it for data lake features such as folder structure and fine-grained security. So by this I mean that we need to create folders within folders, right? So if we have this checkbox selected, we can create directory. In that directory, we can create folders. In this folder, I can create subfolders, and in that subfolders, I can store my data. So I can create three folders, and in these three folders, I can store three different types of data. So this support of directories or creation of subfolders, it will get enabled by this enable hierarchical namespace. Then the second advantage is like it will allow you to have file or folder access control. By this, I mean that as we are going to create three different folders, right? Bronze, silver, and gold. And we are going to create our Databricks too. So this Databricks is going to interact with these three different folders for any purpose, maybe to access the data from bronze level or to store cleaned and transformed data into silver or gold layer. So as it is going to have that interactions with these storage account, or in this case maybe ADLS Gen2, we need to set some kind of permissions to access it. Otherwise, Databricks won't be able to access these data files which we are going to store. So this fine-grained access controls, those will be set by enabling hierarchical namespace. And apart from this, it will also give the benefit of better performance when we are dealing with these big data tools. In our case, right now, it is Databricks. Synapse is also there, but right now, with this project, our big data tool will be Databricks. So we need to, or we must need to enable this hierarchical namespace while we are creating this storage account. So I have checked it. Then we have these access tiers. We have these three different access tiers. One is hot, cool, and then cold. So to simply understand it very shortly, what we will do. So our first will be storage cost. Then the second will be our access cost. And then third will be purpose. So the storage cost for hot tier, it will be high, but the access cost will be low. For the cool tier, okay, so the purpose for this hot tier would be to access frequently used data. For that, we need hot tier. Then the next one is cool tier. For the cool tier, storage cost would be lower, but the access cost would be higher. And the purpose would be to access infrequently accessed data. And the cold tier, which is nothing but again archived tier, the storage cost would be lowest, but the access cost would be highest. And the purpose of this would be to store the long-term storage data or to store the backup, which we are going to access very infrequently, which would be like within 180 days. So for that, we are going to opt for the cold tier, which is nothing but the archived tier. So right now, in our case, we are going to access the data frequently, so hot tier would be preferable. So I'm going to select hot tier, then click on next. Networking, no need to change anything. Data protection, keep it as it is. Encryption, tags, no need to change anything. Lastly, it will give review plus create. Just click on create. So deployment is in progress. Now our deployment is completed. Then I'll click on go to resource. In that we have data storage, containers, then file shares, queues, and then the tables. So I'll click on containers, and in here I'm going to create 3 containers or 3 folders. So I'll click on add container. The first one would be bronze, then the next one would be silver, and then our third container would be gold. Okay, so now our 3 storage containers are ready. Now the next step is we are going to create our second Azure service, which is SQL Database. So I'll go to our resource group again, then click on create, type SQL Database. So this is the one. So select this second SQL Database, click on create. So if you'll see, it is giving us offer of 32 GB. Okay, so I'll select that apply offer. So my billing will be disabled and it will cost me 0 USD. Otherwise, it will cost you some around $4 or $5 USD. Subscription is correct. Resource group, this is not the resource group which we have created. Our resource group is RG Adventure Works. So I'll select the correct resource group. In case required, we can create new resource group from here too. I'll select the one which I have created just now. Then we need to give our database name. So maybe Azure SQL Database Adventure Works. Okay. So now the next option is server. I have already existing servers, but in our case, I'm going to create a new server. So I'll just click on create new. And in here, we need to give our server name, maybe Azure server name, sorry, Azure Database Server Adventure Works. Location is fine. Authentication method, I'm going to use both SQL and Microsoft Intra ID. Server admin login, I'll give maybe Rutuja admin. Then the password set accordingly. And you need to remember this admin login and password for our further procedures. Maybe I'll just snip it. Okay. So what is it giving error? It can contain only lower cases. Okay. That would be fine. Okay. Now click on OK. So this value must not be empty. We need to set intra ID admin 2. So once you will select that, you need to give the access to your account with which you have logged into this Azure service. Select it and click on OK. So let's try to understand this. What is this Azure SQL Server which we have just created? Okay. So this Azure SQL Server is a server which is nothing but a logical container or a management boundary for your Azure SQL database. So this is nothing but our logical container. Right now we are talking about this Azure SQL Server, okay? So this logical container or a management boundary, that it means that it does not have any physical machine, okay? It doesn't mean it has any physical machine, but it has a logical server endpoint that will manage your database. So this database will be managed by this Azure server, which is nothing but a logical container. So in short, think of it is like a folder or a namespace group which will group these databases under one management scope. So this will be a logical container which we will assume it as a folder, and under this folder we are going to have this database which we are going to create, and that will get managed or grouped within this logical container. So right now we are going to have this one database, okay? But if you have multiple database, you can create these multiple databases under this server name, okay? So you can have multiple databases. This will be one. Maybe in future, if you would like to create another databases, so you can create those databases under this Azure SQL Server, okay? So after this SQL Server, if we say like why we need, um, if we can say that why we need it when we are creating this Azure SQL database, right? So the first one or the first reason would be database organization. So this database organization means the server group of one or more databases together. It would be easier for the management with this Azure SQL Server. So this database organization would be the first reason. Then the second reason would be security boundary. So this server basically defines us firewall rules. Then we have admin credentials, which we have set, if you remember, which where we have created this credential and then we have set the password. So that server level admin login, that got enabled by this SQL server. Then it will also enable our security policies. So auditing or threat detection, that will also get enabled under this security boundary for this SQL server. So this is the second advantage or second reason for the need. Then, then the third one would be the resource management. So under this resource management, we can manage our pricing tiers or performance settings or geo replications. Those will get managed at the server level. So these are the three reasons: database organization, security boundary, and resource management. For these three reasons, we need our Azure SQL Server for our Azure SQL Database. Okay. So what happens if we reuse this Azure existing SQL server, right? In this situation, what we have done, we have created the new one. So if what if like we use the existing one, okay? So if we use the existing SQL server, then in that case, what will happen? Our new database that will get created under that server's namespace. So this one is our existing one. Our new database will get created under this server name. Suppose let's say it has already two databases. So our third new database will get created under this server. So this means that it will share the same login and firewall setting which has been set to already existed two databases. So that will get shared by our third newly created database. And we can say that it is useful if you want multiple databases to be managed under the one logical server. So in that case, it will be beneficial to use the existing one and not to go for the new one creation. Okay. So in short, Azure SQL Server is a logical container for our databases. Plus, it will give you security boundary. And under that, we have this SQL database. So this is nothing but the actual database of our data. Okay, so that will get managed by this SQL server. So click on next. We have here compute plus storage, but we don't need to create anything. Okay, so the compute maximum cores 2 are fine, minimum 0, apply. So the general purpose serverless compute is fine for us. Click on next. Then we have this connectivity method. So select public endpoint. So in this connectivity method, right? So when we are creating this Azure SQL database, right? This connectivity method determines how your client can connect to your database. Okay. So no access, it means that no one can connect to your database externally, not even your another laptop or whatever you are doing on that. So you won't be able to connect to that. Okay. Then we have this public endpoint. That means that the database can be accessed over the internet using your public IP address, which is protected by the firewall rules. Okay, so you can connect using your server name, which we have created. In our case, it was like your server name plus server name dot database dot windows dot net. So you can connect using that server name. But in that case, you need to allow, or it is must to allow your IP in the firewall settings. So this SQL database will have firewall settings. In that, you need to allow that particular IP address. Okay. So this is how this public endpoint will function. And then the third one is private endpoint. So this private endpoint, it connects your SQL server to a private IP address in your Azure virtual network. So in this situation, amongst these three endpoints, we are going to opt for the public endpoint. Then click on next security. I'll keep all those settings as it is. So the costing would be 0 USD. Okay. And I'll click on create. So first it will validate and then it will deploy your Azure SQL database. Okay. It will take some time to deploy. So after this second Azure service creation, now we are going to see how we can fetch our data No, first we will see how we can, this will be our SSMS on premise one. We will try to upload this data, adventure data into SSMS, and then we will connect this SSMS to our Azure SQL database, which we have created just now, and we will try to pull that data from SSMS to SQL server. So this will be our next step. Now, till this deployment gets completed, we will see how we can work on this next step. So our deployment is completed. Go to resource. So this is our SQL database and this is our server name. Okay, so we are going to require this server name. So for that, what we will do, we will just copy this server name. Then I'm going to open my SSMS account. So if you don't know how to download these SSMS and everything, so just refer my previous project, which is second project. In that I have mentioned all the steps to download these SSMS. So here server type would be database engine. Then under the server name, which we are going to paste the server name which we have copied from here. So this server name we are going to give here. Then we are going to select this SQL Server authentication. And here we need to give login and password. So if you remember, we have given this login and password, admin login and password here, right? So this login and password we are going to refer over there, okay? So in my case, the server admin name is Rutuja admin and the password which is set by me. So give that login and password here. Remember password, encryption, I'll just say optional, or what are the option? Maybe strict. Then click on connect. Then it will say that you are not signed in to Azure. So click on sign in. So instead of, I'll just paste this here. I'm going to pick my account. So it states that your authentication is completed. Then go back to your SSMS. Now we are signed in, okay? So click on OK. So we can see that now our database, Azure database, which we have created, we can access that database from here too, okay? So this is our server, SQL server. Under that, we have created our Azure SQL database, which is ASD Adventure Works. And in that, right now we are not going to see any tables here. So this is how we can connect to our Azure SQL server from SSMS. Now let's try to connect with our query editor. So just click on query editor here, then give the password which has been set by you. Click on OK. So this is our Azure query editor. Right now under the tables we will not see anything. Now the next step is to download all the files. So this is our Kaggle website. So download all these 6 or 7 files. Once you download it, go to your SSMS. So under the SSMS, we have this Azure ASD Adventure Works SQL database, right? So right click on that, then click on tasks, then import data files. Okay. So by this, it will import the data to SSMS, and Parallelly, it will, as we have our Azure SQL database connected, it will get pulled to our Azure SQL database also. So click on next. So browse your file which you have downloaded onto your local PC. Click on open. So we have 7 files. So we are going to create 7 tables for that. So first file is product file. I'll keep the table name as product only. Schema DBO is fine. Click on next. Next. So this is how our data will look like. Then click on next. So now we can see we have these column names with those respective data types. If you would like to change, you can change the data type from here too. So right now in this case, what I'll do, the product key will be our primary key. So it should not allow any null values. So I'll set the product key as primary key, and rest of the keys, those will be non-primary keys, but it can allow the null values too. So for that sake, I'll select the allow nulls, click on next, finish. So it will set that inserting data is success, then close. We'll refresh this. Then we should see one table here. See, this will be our dbo.product. Similarly, we'll go to our query editor, refresh it. Under the tables, we can see we have this dbo.product. Okay. So maybe select top 1000 rows. It will give you all the data, or at least not all the data, initial top 1000 rows of that table. So this is how our data looks like. Okay. So now it's time to upload the second file. Same, right click on your database, then go to tasks, import flat file. Next. Now our next file would be the region. Click on OK. Table name region is fine. Click on next. This is how our data will look like. Next. So in this cell's primary key we will set as primary key, and for the rest of the non-primary values or keys, we will allow the null values too. Okay. Next, finish, success, close. Now it's time to upload the third one. Again, go to the tasks, import flat file. Next, browse, product is done. Okay, reseller, open. Table name reseller is fine. Next. This is how our data will look like: business, reseller, city, province, country. Okay, next. So here reseller key we will set as primary key. For rest of the columns we will set, it can allow the nulls. Okay. Next, finish, close. So till now we have uploaded 3 tables. Okay, so we are still left with the 4. Refresh it. We can see those 3 tables here also. So now quickly upload all the remaining 4 files here. Tasks, import flat file. Next, browse. After reseller we have sales, open. Table name sales. Next, this is our data. Next. So in here we don't have any primary key, so we can allow null values here. So if in case in this situation, maybe if you are getting confused which one to assign as a primary key and how I can allow the nulls, so in that case what you can do, you can refer our Adventure Works data too. So if you'll go here under the columns, it states that product key is the primary key. Okay, if we'll go to the region, it will say that sales territory key is our primary key. So similarly for the sales, we'll see for the sales here it has not given any primary key information. Okay, so for this we don't have any primary value. So you can, for the simplicity, you can refer this AdventureWorks Kaggle dataset too. Under that you have column section and you can refer that too. Okay, again coming back to our SSMS. Next, finish. And in this situation also, if by mistake if you have assigned a non-primary key as a primary key column, then here at the last step in the results it will give you either warning or the error, and in that they will mention what's the exact error is. Okay, so you can verify from there too, and you can, suppose if you get any error, just come back to the previous step, modify that step, and again click on next, next, next till your data gets inserted successfully. Okay, so click here in the warning. Now in the warning it is giving you up to 235 has been dropped for the while inserting the data. Maybe there might be any issue in the respective column, so we are fine with that. We are okay with that. Just click on close. Now we are done till sales. Click on tasks again, import flat file. Next, sales is done. Salesperson region. Okay, open table name, fine. This is our data set. Click on next. In here, let's refer to our data. So employee key is the primary value. So we will assign this as primary, allow nulls. Okay. Cannot insert duplicate keys. So in this situation, it states that employee key is the foreign key for salesperson. Okay. So that means that we have forgotten to upload our earlier file, which is salesperson. So for that, I'll come back to SSMS. If we'll see, we have uploaded till sales. Okay, 4 files has been uploaded. Come to tasks, import flat file. Next, browse. Salesperson is left, for which we have, next we have this employee key as a primary key. So for the remainings we will allow the nulls. Next, finish, close. So now the next one is adventure region. Sorry, sales. What was that? Next, browse. This one, salesperson region, for which employee key was the foreign key, not the primary key. Next, so for this, it means that we need to allow the nulls. Click on next, finish, close, and just refresh it. Tables. Okay, now we are left with tasks, then import files. Next, browse. Okay, the last one with which we are left with is the targets. Open, table name targets. Next, this is our data. Okay, this employee ID refers to the salesperson table, so this is not the primary key. Then click on next. We don't have primary key, then that means we need to allow the nulls, finish, and close. So refresh it. So if you'd like to do some kind of analysis on the raw data, then you can do that into your SSMS too. Suppose select 1000 rows, then it will give you all the data. You can do the analysis from here too. We must be having our data into our Azure SQL database too. So this is the data which we have. Select 1000 rows maybe. So you can do your analysis into cloud service. If you would like to do it into cloud service, then you can do it into Azure SQL database also. So now this is our first step where you have your data into Azure SQL database. And now we will see how we can pull our data from Azure SQL database. If you remember, this is our Azure SQL database and we have our data here. Now we would like to pull this data into our ADLS Gen2. In that we have this bronze layer. So we need to pull this data into bronze layer. For that sake, we are going to create ADF, which is Azure Data Factory, and in that we will try to see implement copy activity or for each activity, and with this we will pull our data from this Azure SQL database to our bronze layer of ADLS. Okay, so now this is going to be our next step. So let's see. First create this Azure Data Factory and let's try to implement our activities into that ADF. Okay, so now move ahead and create ADF. This is my resource group. In that I'll click on create. Then in the marketplace we will search for data factory. This is this second data factory we need to select. Here create. Then this is our resource group, the correct one. Now you need to give name to your Azure Data Factory, maybe ADF Adventure Works. Region East US version, we have only V2 version. What it states, it has been taken. Okay, maybe. Okay, Adventure ADF Adventure Works copy. So this name is not taken, so we can assign this name to our Azure Data Factory. Click on next, 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 review plus create, create. So deployment is in progress. Succeeded, go to resource, refresh, refresh. So this is our data factory. We will launch this Azure Data Factory. Launch Studio. So this is the portal of Azure Data Factory, in which you have Home, Author, Monitor, Manage, and Learning Center. We'll come to the Author tab. Here we are going to create our pipeline. Under the Monitor section, so suppose let's say you have created your pipeline and then you have triggered your pipeline or published your pipeline. And then you need to, after the creation, you need to keep the track of the pipeline which you have created, whether it's successful or failed. If in case it fails, then what's the reason? So to debug that, you need to come to this monitor section where you can monitor your triggers, pipelines, then integration runtimes which you have created. Under the Manage tab, you can create linked services, runtime, integration runtimes. You have Microsoft Purview too. You have triggers, global parameters. So all these get managed under the Manage tab. And Learning Center, if you'd like to explore more tutorials or videos, you can explore that from here too. Right now, we are going to create our pipeline. So before the creation, let's try to see how our pipeline will look like into Azure Data Factory. This is how our ADF workflow will look like, in which we will create our pipeline. So in here we have source and sink. So in our case, the source is our Azure SQL database, and the sink will be our ADLS Bronze layer. So this source, and after the source and sink, we have linked service at both the ends. We have linked service, one linked service for our source side and the second service for our sink side. Okay. So this linked service is the connection to your data source and the sink. Okay. So these define where your data is coming from and where it's going. Okay. So this linked service on the source side is the Azure SQL Database linked service. So it connects to your Azure SQL database that holds your 7 tables. Okay, so it will help us to connect to our 7 tables of your Azure SQL database. Okay, and then the second one is ADLS Gen2 linked service. So it connects to your ADLS Gen2 where the bronze layer files will be stored. Okay, so this is the link service on both the ends. Then we have integration runtime on both the ends. Okay, so this integration runtime, this is the compute infrastructure which is used by the ADF to perform this data movement or the transformation, or we can say the dispatch activity. Okay, so to perform this movement from source to sink, we need integration runtime. And this integration runtime, we have different types of this integration runtime. So the first one is the one which is Azure integration runtime, which is for the cloud, which we are going to use. Okay, so this will be our auto resolved IR. For this sake, we don't need to create any kind of additional IR. With this auto-resolved IR, which is given by the cloud, we are going to use that for our source and sink. Okay. So this one is the Azure IR which we are going to use. There are other ones also, for example, like self-hosted IR. So to connect the on-premise SSMS, okay, we need this self-hosted IR which we need to set explicitly. But right now, in our case, both are the cloud services. So for that, we don't need to create any additional IR. We can opt for the by default IR, which is auto resolved IR, which is given by the Azure. Okay, so we are going to opt for that one also, that one only. Then the next step is dataset. Again, we have dataset on both the ends. So this dataset in ADF represents the structure of the data that is used as input or the output in the activities. Okay, so it's like a blueprint. So these datasets, these are nothing but the blueprint of your data source or the destination. Basically, it will describe like what to connect to. In our case, what to connect to is Azure SQL Database. Then which tables or files access to. In our case, these 7 tables we need to access, and in what format it's in. So in our case, these are in table format. So this kind of information is stored into the data set. Okay, so similarly it goes for the sink also. At the sink side, it will store the information about ADLS Gen2. Okay, so the purpose on the source side is to read the data from Azure SQL table, and at the sink the purpose will be to write the data to the specific location. In our case, it will be the bronze layer in ADLS Gen2. Okay, so this is the information which gets stored under the dataset activity. Dataset activity, okay. Now the next one is the actual activity, which is copy activity, and then the for each activity. Okay, so this copy activity, it will copy our all these 7 tables from Azure SQL to the bronze folder. But what happens is, like, let's say suppose for the product file we have implemented this copy activity and then it has been copied to the bronze layer. So now next we have sales table, right? So for the sales table, again, we'll need to create one more copy activity. Then again, for the third table, we'll need to create another copy activity. So in such a way that we'll need to create 7 copy activities. So it will be a redundant task and it will not be preferred to have 7 activities, okay? Because the purpose is same, to copy the table from one location to the another location. So for that, instead of creating 7 activities, what we will do, we will just create one copy activity and then we will loop this activity for 7 times. Okay, so to loop this activity, we will use this for each activity. So the purpose of this for each activity is to execute the same logic multiple times. So once for each activity in our table list, it will implement this same logic for the 7 times and it will copy all our 7 tables to our destination instead of using 7 different copy activities. So this is how our ADF workflow looks like. So now let's try to implement this ADF workflow. So for that, we are going to create 2 linked services. And for these 2 linked services, we will have 2 datasets. And then we will have for each activity, and under that for each activity, we will have copy activity. So these are the steps which we are going to implement in our ADF implementation. So now let's move ahead and see the practical part for this Azure Data Factory. So first we will try to create 2 linked service, one for the source and another one for the sink. So for that, come under Manage tab. Then under the connection, we have this linked services option. Click on New. Our source is SQL Database. So we will select this Azure SQL Database for our linked service. Click on Continue. Then we need to name our linked service. Maybe Azure SQL DB LS. Then this is the IR integration runtime, which I have told you that we will use, which is given by the cloud, and this is auto-resolved IR. We'll keep it as same. Then Azure subscription, we need to select our subscription. Under the server name, we need to select our server name, which is ADS Adventure Works. Then the database name, our database name is ASD Adventure Works. Then our authentication type is SQL type. Then we need to give username. Our username was Rutuja admin. Then we need to give the password. If you would like to save your password dynamically, then you can save your password into Azure Key Vault and create one new linked service for that. In my previous project, I have explained how to create this new linked service for the Azure Key Vault. If you would like to opt for this option, then just refer my previous project. So as of now, in the password, I'll give the password which I have set. Then the encryption, we would like to keep it as mandatory only. Trust server certificate. Okay, and now we will test the connection. So it states that connection has been failed. Cannot connect to the database. Contact server team. Okay, so this issue is might be occurring because we didn't set our IP address. So for that, come to our we need to go to our SQL database. So here under the security, where is that option? I think it's not that SQL database. We need to go to SQL Server. Then under the security, we have this networking option. Here we need to make sure that public network access selected networks has been selected, and then scroll down and under the exception select allow Azure services and sources to access this server and click on save. Once you have saved it, again come back to your linked service creation, and then we will try to test our connection again. Now it states that connection has been successful. So we will just create this new linked service. So one linked service has been created. Now again we will create another one for our sink, which is Azure Data Lake Storage Gen 2. Select it, continue. Then give the name ADLS, maybe Bronze linked service. IR we will use the by default given IR, which is auto resolved IR. Then account key, subscription, select your subscription. Then storage account, ADLS Adventure Project. Then first we will test the connection. Connection is successful, and now we will create our second linked service. So both has been created. Now we need to go for our copy activity and for each activity. So for that, come to the author section. Here, click on the pipeline, right click on these three dots, then new pipeline. Maybe we will give pipeline name as Azure SQL DB copy to ADLS Bronze. Okay, so now first we will take for each activity for the iterations. So before this for each activity, we will set variables first. So for that, click on this blank area. Then you will get the option to set parameters, variables, settings, and output. For that, come under variables section, click on new. Then we will set variable name as table name. And in this variable, we will assign all of our seven table names. Okay. So the default value, we will give it as an array with these 7 table names. Just copy this, and we will assign this default value to the variable named as table name. Okay. So this variable has been set. Now come for this for each activity. We will change the name of this for each activity, maybe loop to tables. Then come to this settings, and for these items we will add a dynamic content. Okay, so for this dynamic content we will take this variable name. Okay, so come to this variable section. This is the variable which we have set, in which we have 7 table names. So you just click on this. Okay, I'll remove this. If you'll just click on this, it will give you as @variables table name. So now under this variable name table name, we have 7 table names, and our for each activity will loop on these 7 table names. Okay, so this is the logic which we are implementing. So this is how this for each activity looks like. Now under this for each activity, we are going to have our copy activity. Okay, so for that, come to this edit section. Then from the activities, just pull our copy activity here. Maybe we will give the name as copy to bronze. For this, then come to the source section. Now this is the time where we are going to create our two dataset. One is for the source and another one for the sink. Okay. So for this source, we are going to create a new one and our source is SQL database. So we will select Azure SQL Database, click on continue. Then we are going to give name, maybe Azure SQL source dataset. Then linked service we have already created, just select that. Then we'll select this drop down under the table name. We have all these 7 table names, okay? But as of now, we will not select anything because we are going to use for each activity. So keep it as it is. Import schema none is fine. Then click on OK. Then we are going to have another data set for the link. Click on new. This will be for our Gen2 account. Continue. Our files would be in CSV format. Click on continue. Then we need to go assign one name. Maybe Azure ADLS sync dataset. Then linked service. We have created this one. First row as header. Then we need to select our bronze folder. Click on OK. Right now we will keep directory and file name blank. Just click on OK. Now what we will do, these are our two data sets. So this is our sync dataset and this is our source one. So come to our main activity. Under this we have copy activity. So this is our for each activity and under this we have this copy activity. So to run this for each activity on this copy activity, we will use query as query. So by default it will be table. So select query option. So under the query section, click on that and click on this add dynamic content. Here we will give @concat. We will use concat function. And under this concat function, we will use our select query. So our select query would be select star from, then DBO. Our schema name was DBO, and under that we have dot schema name dot table name, right? So schema name dot, and then table name we would like to take it from for each activities table name array which we have assigned. Okay, so here comma, then @item. So this will pull those table names, comma, and again into inverted commas we need to complete our square bracket and then round bracket complete. So this will be our expression builder where we will use query select star from dbo dot. So in short it will function like this: select star from dbo dot product. Then the next one will be DBO dot sales, DBO dot region, and likewise. So these names would be taken from the array or the variable which we have created, and in that we have assigned this array with each of these 7 table names. So those table names will be fetched from that array in here. So this is how our expression builder function will work. So click on OK. So now the next change would be come to our sync dataset. Under the sync dataset, select this parameters option, and we will give 2 parameters, okay? One for the folder name and one for the file name. So our one name parameter name would be folder name, type string would be fine, assign second name as file name. Then come to this connection sections again. And in here, if you remember, we need to give directory and file name, right? So in here, what we are doing, we will assign directory name as add dynamic content and then folder name. Okay, select this folder name parameter, click on OK. Then file name, add dynamic content, file name, click on OK. Okay, so file path we are assigning it as by default, sorry, dynamic. Likewise, suppose we are pulling our data, right? And this is our bronze folder. So what it will do, so the first table name is our product name, right? So when it is pulling product table from Azure SQL to this bronze layer, what it will do, first it will create one folder and that folder name would be product. So there will be another folder, that folder name would be sales, another one that would be region. So there would be total 7 folders within this bronze folder. So basically these will be subfolders within this bronze main folder. So this folder creation as per the table names will be done by this variable, which this parameter which we have set here. And in this product folder, then there will be product dot csv file, and here again we will have sales dot csv file. So under these subfolders there will be our csv files, and those csv files file names will be created by this dynamic parameter, which is dataset dot file name. So for that logic, we have assigned these 2 parameter names over here in the file path. Okay, so this is done. Then come to our copy to bronze activity. So if you'll see here under the sync section also, we will get this folder name and file name. Okay, so under this folder name, add dynamic content, and we will select loop through tables, and here we will get all the item values from for each activity. Then for this file name, so the folder name would be our all the 7 table names which we have assigned as an array. Okay, those items will be here. And then file names, add dynamic content. Then again we will use concat function, and under this concat function we will have our items, then comma, and then dot csv. So what does it indicate? It indicates that when we are getting our files, right? So let's say suppose this is my product subfolder, and in this product subfolder I would like to have our CSV file, right? Then my CSV file would be item.csv. Then in here my file would be product.csv. Under sales subfolder, my CSV file would be sales dot CSV. Similarly, it will go for all the 7 files. Okay. So for that, we have assigned or we have concatenated our item with .csv. Okay. Then think we are pretty much done. So we will come to our main activity. First, we will publish all because we need to save our data. By mistake, if we'll just close this ADF and if we haven't published anything, then all of our work will be gone and you will need to rework everything. So it's always a good practice to publish all the things at the correct place. Okay. So now we will click on first we will validate, close, and then we will debug. So let's see if our so for that I'll open our ADLS folder. So we are expecting our data into bronze layer. Okay. It has been failed. Let's see what happened. So the error states that the execution of action failed. The result of evaluation for each expression table name is of type string. So all the time we said it that we have assigned an array, but we didn't change the type of the same. Okay. So for that, we'll come to variables. Here we need to select the correct type, which is array, because we have given the values of array, but the type is string only. So because of that, error has been occurred. So now let's publish again. Now let's debug it. So this execution will take a couple of minutes. Okay, now our activities, all the activities are successfully executed. So now let's just cross verify it. Come to our bronze folder. Let's just refresh it. So now we can see that we have 7 folders of 7 table names. If we select any table name, then we can see that we have that respective CSV file here. Okay. So let's just download this file and just cross verify if it is working fine or not. Okay, it's fine because we are getting column names too, because many times it happens that you will not get column names because we forget to select that first row as header option. Let's just try to cross verify it for one more column, one more file, target.csv. Okay, so we have column names here. So that means that our copy activity has been executed successfully. So now let's move on to our next part where so we will come back to our resource group. Again, we will create Azure Databricks from our marketplace. So just type Databricks. So this first one, select this, click on this create. Subscription is fine, resource group is correct. We need to assign Databricks workspace, maybe DB Adventure Works. Region East US is fine. Pricing tier, we are going to opt for the trial option, which will be for 14 days free. Then we are going to assign managed resource group name, maybe managed ADB adventure works. So we are assigning this resource group so that when we are creating this Azure Data Factory, right? So we are assigning or we are creating this Azure Data Factory under the resource group which we have created, which is RG Adventure Works, right? But while creating this Azure Data Factory, Azure is going to work on so many resources in the backend, and for those resources, we are going to give one folder name here so that Azure can keep all those resources which Azure is going to create in the backend under this managed ADB Adventure Works group name, resource group name. Otherwise, if you'll not give this name, then also there is no issue. Azure will by default assign one resource group name, and under that, it will keep all those backend resources which they have created. So it's always a good practice to assign or give one good name for the same, so that going forward, if you would like to analyze anything, then you can refer to this resource group by default. So that we are going to assign this managed resource group name. Networking, fine, encryption, security tags. Then we will click on review plus create. So first it will validate and then we will create this. So we can see that deployment is in progress and it will take some time to deploy this Azure Databricks and get it successful. But till then, we will just see what is exactly Unity Catalog is. So let's try to understand the concept of Unity Catalog. So Unity Catalog is a data governance solution that is built into a Databricks. So altogether, we can say that we can think of a central system, and this central system helps us to manage basically who can access the data, then what data they can access, and how the data is organized and secured. So it brings organization-wide visibility, control, and security to your data in this Databricks Lakehouse platform. Okay. So if we think of a big picture here, so Unity Catalog is all about governing your data better when you are using Databricks into Azure. So we can say that before Unity Catalog, things were more scattered and very harder to manage. So for that, this Unity Catalog has been introduced. So let's break down it visually. So without Unity Catalog, first we will see without Unity Catalog and then we will see with Unity Catalog. Okay. So without Unity Catalog, or if we say like why this Unity Catalog was created. So before Unity Catalog, the data access control in Databricks was managed separately. So if we can see here, we have, let's say, suppose two Databricks, Databricks 1 and this is Databricks 1 and this is Databricks Workspace 2. Okay. So before Unity Catalog, we can say that these both Databricks workspaces were managed separately for each of them. Okay. So because of that, what used to happen? It was very hard to audit your data. And because of that, it has very limited in supporting multi-cloud governance. Okay. So these were the issues which were before Unity Catalog. So in Databricks workspace, we can say that we have user management, Metastore, and then the compute. Okay. So imagine this situation. Let's say suppose if we are imagining this situation before Unity Catalog, then there is one scenario where you have multiple workspaces in your Databricks. Okay. For example, maybe dev system, test system, or dev environment, then testing environment, and then production environment. Okay. So let's say suppose we have these multiple workspaces or multiple environments. So each workspace used to store and manage its own data. Okay. So each workspace used to have user management, separate individual metastore, and then individual compute. So what is user management? User management is, or we can refer this to how you control who can access what in your Databricks workspace at each level of the object model. So this is nothing but your user management. Okay. Then the second is Metastore. So Metastore is like a warehouse manager. So basically it keeps the track of all your data assets and their permissions. And then we have compute. So compute is the processing engine, like for example SQL warehouse that runs your query, or maybe SQL queries, or in our case those will be our notebooks. Okay, so that's the purpose of compute. So before Unity Catalog, these each of these workspaces were managed separately, or we can say that each workspace used to store and manage its own data. So as it is managing their own data, that means that each workspace has its own security rules and own data catalog. Because of that, what used to happen? Data is not shared easily between the workspaces. So it was very difficult to use another workspace's data. Okay, suppose I have my data into this second workspace, so it was very harder for me to fetch that data or to read that data from the first workspace. Okay, so if you, in this case, if you would like to apply data governance or any access policies, you must do it separately in each workspace. That means each workspace has different governance or access policies. So in this case, obviously there is no central data or central view for all of your data. Okay. So in basic scenario, let's say suppose if we'll take the example, so every department in your company has their own filing system. Okay. So as each of the department in your company has their own filing cabinet, but they use the different formats, different logs, and they don't share their files with each other, right? So it's very confusing to not to share the data with each other, right? In even if you are in a same company. So this is the example for this. So let's say suppose this was the scenario before Unity Catalog, and then afterwards this Unity Catalog was introduced. Okay. So let's see what happens with Unity Catalog. Okay. So scenario is the same. We still have multiple workspaces, for example, dev, test, and prod. But in this case, Unity Catalog acts as a central brain that manages all of them. So in this case, what will happen? Now we have here two different workspaces, and in these workspaces they have, each of them have different compute. Okay, but the user management and Metastore, which is managed by the Unity Catalog, is same. So it is governed centrally. Okay, so that means that our data is governed centrally for the multiple workspaces. So you need to manage one metastore across the workspaces. Okay, so you have only one workspace, one metastore that you need to manage, and you can share and manage or access the data across the environments. So in this case, you don't need to worry about, okay, my data is in production or my data is in test environment, how can I access that? So with Unity Catalog, you can access all the environments, you can access all the data, any of the data from any of the environment. So in this, what we'll do, we can just define our catalog, schemas, tables, views, and volumes in one place with Unity Catalog. And we have one more advantage of this, which is you can apply fine-grained access control, okay? Such as if we'll create, for example, if you have created here tables or views or anything, right? Then let's say suppose if I have created table, then if I apply fine-grained access control, then I can control who will access that tables or who can access which column of that tables or who can read the table or who has the access to write or make changes into that table. So that fine-grained access I can apply with this Unity catalog. So again, think that now you have all the departments that use the same digital filing system instead of cabinet system that has shared folders with proper permissions, and you can see what everyone is doing all from one control center. So this is the summary which I can say for without Unity Catalog and with Unity Catalog. So the first one is data access. So without Unity Catalog, it has been managed or separated by workspace. And with Unity Catalog, it is centralized and shared. Then if we talk about the governance, it is managed per workspace. And with Unity Catalog, it is managed centrally. If we talk about lineage and auditing, so it is limited because without Unity Catalog because each one of the workspace has been managed separately. And with Unity Catalog, as each and everything is centralized, it has full tracking. So we can track fully our data and we can track our lineage and auditing too. If we talk about data sharing, it is manual and very complex. With Unity Catalog, it has become much easier and secured. Policy environments, those policy environments has been repeated for each of the workspace. But with Unity Catalog, these are unified policies for all the workspaces. And lastly, security, it's very basic without Unity Catalog, and with Unity Catalog, it is very fine grained. So you can go till each column and row level and you can decide who can access which data. Okay. So in terms of these accesses, there is one more example. So let's say suppose you have a company and those companies has three teams. For example, this is just for example. The one is a data science team, the another one is business analysts team, and the third team is interns team. Okay, and our data lies in Azure SQL. Then we have our data into ADLS2, and we have our data into Delta tables also in Databricks. Okay, so now without Unity Catalog, we can say that you would manage who can access what data in each workspace, that too manually. Okay, now with Unity Catalog, you can create a catalog. Okay, so maybe for our data, we will create a catalog. Then in this catalog, so let's say suppose this catalog is our company data. Okay, then under the catalog, we can create schemas. So let's say suppose for the sales team, we will create one schema. Then for the finance team, we will create another schema. Then for marketing team, we will create one more schema. Okay. Under the schemas, we can create tables. So for example, we have created customers table, then orders table, and revenue table. These are just for examples. Okay. Now we will define everything in one place. Okay, so after defining these catalog schemas and tables, then maybe we can decide, let's say suppose we have one data scientist team, right? So we'll decide maybe data scientist team can access everything. Then we have analyst team, right? Then business analyst team, so we can decide like analysts can only read customers table. So that will be decided by us who can access which data. And then maybe we can say that these interns will access only marketing data. So all together, I would like to say that it is all centrally managed, audited, and secured with Unity Catalog. So this is just one example for the simplification or for the better understanding. Okay. So now the next thing is Unity Catalog Object Model. Okay. So if we say like what is it exactly, this object model basically tells us how your data is organized in Unity Catalog, like how the folders, files, and the permissions are structured in your Databricks account with this Unity Catalog. Okay, so this is the object model which we are also going to create, and I have told you about this in our project outline. Okay. First first one in this Unity Catalog object model is a Metastore. Okay. So Metastore is like a warehouse manager which keeps the track of all your assets and their permissions. Okay. So under and one more thing for this Metastore is that when we are creating this Metastore in Unity Catalog, we can create only one Metastore per region. Okay. So if let's say suppose if we have selected East US region, so in East US region we can only create one Metastore. You can't create another Metastore in this East US. Okay, then you need to opt for maybe Central US and then you need to create the another Metastore. Okay, but for one region there would be only one Metastore. So this is Metastore concept. So after Metastore, inside Metastore we can create catalogs. So this catalog is nothing but a collection of databases. So think of this catalog as a folder. Okay. So this is nothing but a folder where we will have the collection of databases, nothing but schemas, databases slash schemas. Okay. Then under the catalog we will have schemas. So schema or database is nothing but a collection of tables and the views. So it basically organizes your data into a folder, and that folder is nothing but a catalog. Okay. So this is nothing but a collection of tables and the views. And then we have this table, view, volume or function. So table is nothing but your actual data, just like a spreadsheet or a database table. Okay. Then we have views. Views are nothing but virtual table based on a SQL query. Then we have volume and functions. Volume is nothing but a storage for unstructured data, for example, images or the PDFs. Okay. So tables, views, volumes, function, those will be stored under schema. Schema is nothing but a collection of tables and views. Such kind of schemas will be stored under a catalog. Catalog is nothing but the collection of these schemas which acts like a folder. And this catalog will come under one Metastore per one region. So this is how this object model look like, and the same object model we are going to create. We are going to now we have created our Databricks. Into that we are going to create one Metastore. In that Metastore, we are going to create one catalog. Under the catalog we are going to create three schemas because we have three layers, right? Bronze, silver, and gold. So we will create three schemas for our three layers, and in those schemas we will create the tables. So we will create seven tables for silver layer and then seven tables for gold layer. And once these will be cleaned tables and these will be transformed tables, and then we will access these transformed tables using Power BI to create dashboards. So this is how we are going to work further. Hope I am clear with these concepts so that we can implement this object model into our Databricks. So now let's move on to our practical part and we'll implement this model now. So now our deployment has been completed. click on Go to Resource, then launch your workspace. So this is our Databricks workspace. So now as we are going to implement our Unity catalog, our first step was to create a Metastore. Okay. So to create a Metastore, we'll check under our account, we'll see there will be no manage account option here. Okay. So it's, if you don't have manage option here, then what you need to do, you need to go to this link accounts.azuredatabricks.net/login, and here you need to continue with your Microsoft Intra ID. So once you will click onto this, go to catalog. So we have this Metastore data catalog which I have created earlier. So I'll just delete this one first. So now we don't have any Metastore. So now we'll see first step to create a Metastore. Okay. So the first one you would like, you'll need to give name for this. Maybe Adventure Works Metastore. Then the region East US. So this ADLS Gen2 path, so what we will do, we will create one more container into our ADLS account, and then we will assign that, or we'll give that container name or container path into ADLS Gen2 path. Okay. So with this, what will happen, this folder or that particular folder which we will have under this path, that will get managed by your created Metastore. So whatever Metastore data that Databricks need to save or need to store, they will store that data to this ADLS Gen2 path. And one with that, we have one more access connector ID which we need to create. Okay. So we need to create this access connector ID because, let's say, suppose we have this Databricks account. Okay. And as we have discussed, we are going to create one container for this ADLS Gen2 path. Okay. So let's say, suppose we have created one container as Metastore data, which we will create under our ADLS Gen2 storage account. Okay. So this folder is created or is handled by Metastore, which we will assign it here. Now, as we will have this folder, we need to store that, or we need to store something into that folder as per the requirement by the Databricks. Okay. So when we need to interact with this Metastore data, we will need access connector ID. So to access or to interact with this folder or container, we are going to require this access connector ID. So this access connector ID will grant that access to this container and Databricks. By this, it means that now we have access connector ID. So with this access connector ID, Databricks can interact with our ADLS Gen2 folders. Okay. So for that sake, we need this access connector ID, and we'll see how we can create it. So firstly, what I'll do, along with this, we have these folders, bronze, silver, and gold. I'll add one more folder, which will be Metastore data. Create. Now we need to give that container name here. Okay. So our Name would be, let me take, so our container name was Metastore Data. Then at the rate storage account name, at the rate our storage account name was this one, ADLS Adventure Work Project. Then dfs.core.windows.net. dfs.core.windows.net and then slash. Okay. So this will be the path of our Metastore data folder, which will be managed by Metastore. Then access connector ID for that, come to your resource group, then click on create, select access connector for Azure Databricks. Click on this, create. We need to give name, access connector ID. Maybe adventure works. Okay, region is fine. Next. Review plus create. So now as our deployment has been completed, we need to assign this access connector ID here. So for that, go to resource, click on access connector ID, and this is the resource ID which we need to copy. So just copy this, come to your Databricks, paste it here, and click on create. This path doesn't exist or we couldn't access it. Okay, so to access this Metastore data, first what we need to do, as we have created this access connector ID, come to your ADLS account. Then we need to assign permissions for the same. Okay, so click access control, click on add, then click on add role assignment, then just search for storage blob data contributor. So this one, storage blob data contributor, click on next. Then select managed identity, select members. So in this managed identity, go for access connector. Here we need to select our respective adventure works ACID which we have created, access connector ID. Click on select and then click on review plus assign. Then come back to Databricks. We'll just verify the name. Container storage account, DFS core Windows Net. Okay, fine. So now it will take this role assignment will take time of 5 to 6 minutes. So let's just wait for 5 to 6 minutes, and again we will try to create this Metastore. Now let's try to create this Metastore again. This part doesn't exist. Cancel. BFSs. Metastore data, container name, storage account name. Okay, so I have created this with wrong name. Again, delete. So Metastore data. So I'll again create a new container with correct name. Okay, so now we have this container, and now let's try to create it. Okay, so now we have created our Metastore, and we need to assign our workspace to this Metastore. Okay, so this is the Metastore which we have created, and we are going to assign it to our current workspace. So I'll just select this Azure Databricks Adventure workspace, which we have just created, and now our Metastore will be linked to this Azure Databricks assign. So we'll click on this and then assign. It will ask you to enable Unity Catalog, and then it will give you some information. So just click on enable. So now it will say congratulations, your adventure work Metastore has been created and it has been assigned to your workspace. So now let's just close this. Then we will go back to our Databricks portal. Okay. So under the catalog, we'll see. Okay, so there is one more thing which I have forgotten. So under this Windows.NET, right, where we were doing or creating Metastore. So once we have created this Metastore, we need to change this Metastore admin. Okay, so just click on this edit, and now it will take you it will take your external Microsoft Intra ID as a admin. So we need to change that, and we need to give your Gmail account or any Outlook, any account with which you have logged into your Azure portal. Okay, so that user you need to select and then click on save. So this is one of the major and important information or thing which you need to change with this Metastore admin. Now come back to your home section, uh, as in to your main Databricks account. So we can create compute from here. I was expecting under the catalog. Let's just refresh this once. See, now we can see as we have enabled our Unity catalog, we have this plus button and we can create catalog, external location, credential, connection, everything from here. Okay. So as we have created our Unity catalog, and because of that, we have assigned our Metastore to our Unity catalog, right? So by default, without Metastore, this Databricks always refers to this Hive Metastore, which is legacy Metastore, which is assigned to this Azure Databricks. But now we are telling our Azure Databricks that you are not going to refer this Hive Metastore. Instead, instead of this legacy Metastore, you are going to refer this Metastore Unity catalog Metastore which we have created, and now you are going to store everything into this Metastore and not into this. So this is the difference between this Hive Metastore and Unity catalog Metastore which we have created. So now we have created our Metastore. Okay. Now our next step is to create this catalog. Before creating a catalog, we need to set external location first for our three of the folders. For that, come to this external data. And before setting external location, we need to create one credentials to access those external locations. So for that, come to this credentials, click on create credentials. Here maybe adventure works thread. And then we will click on create access connector ID. Come back to your access connector ID which we have created. Just copy this resource ID. Then paste this resource ID here. Again click on create. So now our credential has been created. Come back, again go to external. Now as we have created this credential, adventure works cred, now we are going to set three of our external locations. Okay, so click on create external location. The first location would be for bronze, maybe bronze external location. Then we need to give path. ABFSS slash bronze at the rate container name, then our storage account name dot dfs dot core dot windows dot net. Then the credentials which we have just created, we are going to utilize that here. Select your credentials and then click on create. So one location has been created. Test connection, it's successful, done. Come back to external locations. Similarly, we are going to create for silver and gold very quickly. Then the location ABFSS silver at the rate storage account name dfs.core.windows.net slash select your credentials, create. Test connection, all permissions granted. Then the third one, which will be for gold external location. This will be our path, credential, and then create. So now we have our three external locations created. Test connection, successful, done. Now we are going to create our catalog. So this one is done. Then if we see, the second step would be to create a catalog for the collection of schemas. Now click on this plus sign, create a catalog. So we have two options here. We can create catalogs and schemas with this Databricks UI, where you don't need to query anything or don't need to use NoSQL or anything. There is one more way. You go to the notebooks and you type your SQL queries there, and with that also you can create catalogs and the schemas. So right now we are going to refer this Databricks UI platform. So click on create, then catalog name. We need to assign, maybe in our case I'll say adventure works. So this will be our catalog. Type foreign, shared and standard. Standard would be fine. Then we need to select external location. As we have three external locations, we'll not give any external location here as of now, and we'll just create our catalog. Now click on Configure Catalog. We will grant all the accesses. We'll select all account users, privilege, data editor. I'm going to give grant to all the, maybe I'll select all privileges, which option I have here, and select grant. So now next, key and everything, we don't need it. Just save it. So now we have created our catalog and assigned respective permissions to that catalog which we have created. Okay. So now under the catalog, the next step is what? Under the catalog, we need to create this schema. Okay. So I'm going to create schemas for all the three layers. So the first one would be bronze schema. Storage location, I would like to give bronze external location. Then click on create. Now bronze is done. Now silver schema. Storage location would be silver external location. Click on create. Come back. Now the third one is gold schema. External location will be bronze external location. Click on create. So now we are done with this schema creation. Afterwards, we will now do data cleaning and data transformation. And after this cleaning, maybe we will create tables and we will store those tables under silver schema. And then afterwards, after data cleaning, we'll do data transformation. And then we will store all those transformed tables under the gold schema, and that will be accessed by our Power BI. So this is how we are going to work further. So first we will start with creating our compute. So click on compute for that. Create compute. The policy would be unrestricted. Node, single node. The performance runtime 15.4 is fine. Node type we will select maybe for 32 GB memory, 8 cores. Termination time we will give maybe after 30 minutes terminate. And then here there is one more thing. You can see now here you will see Unity catalog because we have enabled our Unity catalog. So it also displays over here. And then there is one more thing, which is when we select single node and access mode, here you need to assign a user with which you are going to work here. So I'll give my email address here with which I have logged into this Azure portal. Okay. So this is the one. Right now it has been selected. That means it's correct one, but it's your responsibility just to make sure that you are selecting the correct single user with which you are going to work further. So after cross verifying this, just click on create compute. So it will take some time, 5 to 10 minutes to create this compute. So let's wait for that time. Now our cluster is ready. So now we will start with our data cleaning process. So for that, come to workspace, select the workspace. It's always good practice to have one folder for all your work. So I'll create one folder. I'll give the name as Adventure Works, create. In this now, I'll create one notebook. I'll change the name of the notebook to maybe data cleaning. 14 days trial, okay. Now we will connect our notebook to the compute which we have created just now. So it says that it's connecting. Okay, so now our notebook has been connected to our cluster. Okay, so I'll just close this, and if you'll see here, so in this catalog tab too, you will see all of the things which we have created. So we can see that this is our Adventure Works catalog which we have created. Under that we have created three schemas. One is bronze, then silver, and then the third one is gold. So the first step is that we always import all of the PySpark functions and types for the good practice. So this will be our code from PySpark.sql, then functions and then the types, and we will import all the functions and the types. For that we will give asterisk mark here. Then shift plus enter. Now what we will do, first we will one by one we will set our respective catalog and the schema for the context. Okay, so first what we will do, we have our data into bronze layer. So to save that bronze layer CSV file into our bronze schema here in the form of tables, what we will do, we will just read that data from the bronze layer, and then we will just write that data in the form of tables into this bronze schema. Okay, so we'll not do any kind of changes here. So once we will save our data in bronze schema, then when we will come to silver schema, in that silver schema we will try to perform our data cleaning process. So the step one would be, first we will set our bronze schema and Unity Adventure Works catalog. So for that the code would be spark.sql, and then into inverted commas we will say use catalog, and our catalog name is Adventure Works, and then again spark.sql, use. Now in this catalog we are going to use our schema which is bronze schema. Here we need to change our language from Python to SQL. Then shift plus enter. Okay, so there is no need to change to SQL. Python would be fine. And then again run this cell. So now we are ready to use our bronze schema. Now we are going to fetch or read all of our 7 files. So this would be the code for the same. The code is very simple, it's just a repetitive statement. So we are going to create data frame for each of the table or each of the file. So DF product, DF region, DF reseller, sales, salesperson, DF salesperson region, and DF targets. These will be our 7 data frames. Okay. The code is simple, and same code we are going to write for each one of these. So read format, then the format of our files are CSV. We'll see here we have CSV file. So header we are going to set it as true. Otherwise what will happen, if header is not true, then your header line will come as your row 1. So to avoid that, header will be true. Then inverse schema, it is true. So Databricks will recognize all of the data types of each one of the column. And then load. And into this load, we are going to set the location of our folder. So here, what is our location? Bronze folder, and this bronze folder is into this data frame. Sorry, this storage account name, which is ADLS Adventure Project. So I just need to change that at all the places. Okay, so this will be our code to read the to read those files into our data frame. ABFSS, then folder name bronze. This will be our storage account name .dfs.core.windows.net and then slash. And if you'll see in this folders, if you'll go to bronze, then we have these 7 folders, right? So we need to give reference of these folders too. So that reference will be given here. So the same thing we are going to repeat for the product, then region, reseller, and for all the 7 files. So we'll just do shift plus enter. Okay. So let's just try to read any one of the data frame, maybe df product dot display. So this is our data frame which is getting displayed as it is. So now we are just going to write all these files in the form of tables into our bronze schema. Okay. So for that, what we will do first, we will define one function and we will just try to use that function to avoid the repetitive process. So for that, what we will do, we can say def write to bronze table, and in this we will pass the parameters df and then table name colon, then df write dot mode. So before this, what we will do, just df then write dot, then we will define the format into which we need to write these. Okay, so the format would be delta, then the mode would be overwrite mode, and after mode we will give one more option of dot option override schema, we will make it true, and then we will say save as table. Then we will set option override schema true, and then we will say save as table, and over here we need to pass where we need to save our data as a table in the form of table. So that would be in the catalog, maybe adventure works, and into adventure works I would like to save it in bronze schema dot and then the table name. Then this would be our function, and then we are going to use this function for all of our 7 data frames. So here our data frame would be df product, but the table name I want it as product. Then for the region, I would like the name as region. So Databricks will give you, it will help you basically to write the code. So this will be the programming, this will be the code which we are going to take. So this is our function which we have defined here, which is write to bronze table. And into this write to bronze table, we are just going to pass our data frame name and then the table name with which we would like to save our tables into our bronze schema. So that name we are going to give it here. So these are our 7 data frames, and these will be our 7 table names which we will see under this bronze schema when we will run this cell. So let's just try to run this cell with shift enter. Now this cell has been run successfully. So let's just try to refresh our catalog. Adventure works, bronze schema, and now we can see that all of these 7 tables are present here. If we'll open any table, then it will give you all the column names along with their respective data types. So let's say suppose if I'll click on this and let's say preview in new cell, then it will give you code, and then you can preview your respective table name or respective table into one of your cells. So now this is fine. Now what we will do now, we will try to do data cleaning and we will try to save our data into silver layer. So for this, what we will do, we will try to read our data from this bronze table. Okay. So for that, what we will do, read from bronze tables. We will set markdown for this, header. Okay, shift enter. Now, as we have earlier, we have utilized our bronze schema, or we have used our bronze schema. Now we will set our silver schema. So for that, spark.sql, then use schema, and that schema will be silver schema. Shift plus enter. So now to read the data from the bronze table, what we will do, we will use the data frame df product again, and then we will say equal to spark dot table, and then into inverted commas we will give the table name as catalog dot schema, and then dot the table which we want to read. So here df product, we are going to use the same data frame names, 7 data frame names, and then spark dot table, and in every for every data frame, then this will be our catalog, and then the schema, and then that respective table which we would like to read. So these 7 tables we would like to read into our 7 data frames. So just do shift plus enter. Now let's try to work on each one of these data frames. So let's just start with df product, df.product.display. So this is our product data frame. In this, maybe we would like what we will do. So this background color format and font color format, these are not necessary for our analysis. So maybe we'll try to remove these 2 columns. So again, this is this is I'm doing this to just to show you that what kind of analysis we can do on our data. It's not necessary that you have to follow each one of these analysis. Maybe from your perspective, the analysis would be different, or data cleaning process would be different, or maybe for me any one of the column is not important, but for your analysis, for the further analysis, that might be important. So you can do changes accordingly, and you can proceed ahead as per the requirement or as per the analysis which you have decided. So let's just move ahead with our analysis and data cleaning. So for that, what we will do, we will keep the data frame as same, and then we will use df.product, and then we will use drop function. and in this we will give our two of our column names. So those would be background color format and then the font color format. And then we will display our data frame. So this is our modified data frame. We can see that those two columns has been removed. Now what we will do, we will try to drop the null values from this complete table. So for that, df product dot na dot drop, and then we will just display our data frame. So this data cleaning would be fine for our product. Then the next data frame is region. Let's just try to read that data frame. So this is the region data frame. So I think that we don't need to make any kind of changes here because we just have only 4 columns and 10 datas here. So we will keep this region as it is. Then the next data frame is reseller. Let's just first read this. So for this, maybe what we can do, we'll just change the column names, okay? So this is state province, we will just change it to province, and this country region, we will just change it to country. So let's just try to implement the code for the same. So df reseller is equal to again df reseller dot, then we will use the function which is with column renamed, and then the column name would be state province, and we will change it to province. And again we are going to use this for 2 columns. So again we will use the same function which is with column renamed, and then the country region, we will change it to country, and then we will display our data frame. So this would be our modified data frame. Now let's just try to remove the null values from this complete data frame. So df reseller dot na dot drop. So basically what it will do, if it will get the entry of any null value, then it will drop that complete row of null value. So this is how this function will work. So this would be our cleaned reseller data frame. Now let's move ahead with the sales table, and let's try to read that table into df underscore sales data frame. So this is how our data looks like. So maybe in here what we will do, we will change the format of this order date. We will just simply take that respective date and not the extended format of this. For that, what we can do, df underscore sales, and then we will use with column function. In this with column, we are going to use order date. Then we are going to change the format of this to date. There is no need to mention column here. Let's just try to remove it. Okay, so now let's try to run this and let's see if the format is getting changed or not. So now see, the format has been changed. 25, 18, 23, 25, 18, 23. Okay, so now the format has been changed. Now let's try to remove the duplicate values or drop the duplicates, sorry, drop the null values, not the duplicate. Sales, df sales, then dot na dot drop, and then display. So I think these changes are fine as of now for the sales data frame. Now the next part is, or the next table is salesperson. Let's try to read this table into our data frame. It has 18 entries and all the entries looks fine. There are not any, like there are not null values or the duplicate values, or the column names are also fine. So we will keep this data frame as it is, will not do any kind of data cleaning for this. Maybe for the data transformation, we will do some kind of changes or advanced modification maybe for this UPN column. So as of now, we will keep this as it is. Now let's try to read our next data frame, which is salesperson region. For this, I think employee key and the territory key, and both for the both null value. Okay, null values are allowed. Sorry, duplicates are allowed, and there are no null values. So this data frame also we will keep as it is. If you would like to do any kind of changes for this, if you believe that that would be necessary for your analysis, then please proceed ahead with that data cleaning part. Then the next and last would be df underscore targets. For this, yes, for this we will again try to change the date format of this target month, and then we will drop the null values. So for this, df targets, then with column target month, here we need to give to date for the same target month. We would like to display it. So first we will drop the duplicates along with this column change, and then we will display it. So shift plus enter. Now we can see that our date format has been changed and the value count or rows count is same. That means that it was not having any null values. That's fine. Now our all cleaned data frames are ready. So again we will define one again we will define one function, and in that function we will write the logic to save these tables into our this silver schema. Okay, so we have already written that logic, but we just need to do some kind of changes into that. Now let's define this reusable function to write our tables into silver layer. So this would be the logic. We are going to define this function named as write to silver table. Then we are going to pass the variables as data frame and the table name which we would like to be into our silver layer. Format we are going to give delta format. Mode would be overwrite. Then override schema we are going to turn it on by passing the value as true, and then save as table, and this would be the location for the table to save that data. So the adventure works is our catalog name, and then the silver schema, and into this silver schema we would like our tables to be saved. Okay, then we are going to use that function for the 7 times for our 7 data frames. So these will be our 7 data frames, and these will be our 7 names of our table. So let's just try to run this cell. Now this cell has been run successfully. So let's just try to refresh our catalog and see if we have gotten those tables. So see these are our tables which we have saved, and these are the columns under that. Now let's just try to view or preview any one of that. So if we'll see, these are the columns, or this is the data frame which we have saved earlier after our data cleaning process. So now what we did, we have saved our cleaned data in the form of tables into our silver schema. So let's say suppose uh, we have created our 3 layers, right? Bronze, silver, and gold. Now I would like to save those tables into delta format in my silver layer which I have created into my ADLS Gen2 account. Okay, for that what we will do, so this will be the program which we are going to run. So silver base path, and we need to give our path here. So silver, and then I need to change our container name here. So this is our container name. So this will be our path where we are going to save our files into delta format. Okay, so these are the code is very simple. It's just repetitive because we have 7 files. So this is the code which we have repeated for the 7 times. So this is the data frame dot write, then dot format. We are declaring our format as delta. Mode we are declaring it as overwrite. Overwrite schema we are saying it as true. Then save, and we would like to save that in here, silver base path, which is this declared path. And in this silver base path we are going to create one folder, and into that folder we are going to save this delta format files. Okay, so this folder name would be product silver. So for the product, I'll give the folder name as product silver. For the region, I'll give the folder name as region silver, and so on for the 7 files. Okay, so now let's try to run this cell with these 7 delta format files. It's running. Let's just wait. Okay, it has been ran successfully. Now we are going to check our silver folder. So now if you'll see here, we have gotten that all the silver layered clean data into those respective folders. So this one is product silver. This one is our delta log, which we have, which got created for the delta format. This is our file, which is into Parquet. So as I have told you earlier, this snappy.parquet file along with this delta log, all together it forms our delta format. In my earlier projects, I have explained about these formats in brief. So if you would like to explore that, just refer my previous project. So now we are done with our silver layer work, which is of data cleaning. Now we will move ahead and we will start with our data transformation. So for that, what I'll do, I'll again go to the workspace. This is our folder. Now I'll again create a new notebook for our data transformation. I'll change the name as data transformation. And I'll connect our notebook to our cluster which we have created earlier. Now let's start with our data transformation process. So the first things first, we will try to import all of our functions and types. So from PySpark.sql.function and then the types. So we'll import all of our function and the types. Shift plus enter. Now what we will do, we will try to read the table which we have stored in our silver schema. Okay, so we'll try to read our first table, which is product silver. So for that, what we will do, we will assign one data frame, maybe DF product, let's say gold, is equal to then spark dot table, and then we are going to give catalog and that respective schema. So that would be adventureworks dot silver schema dot product silver, which is table name. And then we will try to display our data frame. Now let's say suppose for this product data frame, we have this product column. So what we will do, we will split this column into two columns. So the first column name would be brand and the second one would be additional information. So in the first column, we will have the information which is before comma, and in the second column, we will have the additional information which is after comma. So that would be 58, then red, black, ML, whatever it is, which is after comma. We will take that information into second column. So for that, what we will do, we'll just use our existing data frame. Dot, then we will use with column function. And with column, we will give our first column name as brand, comma, and then we will use trim function. And with trim function, then we will split our column. So then first trim, then split, then we will give our column name, which is product, and then we would like to separate it from comma, and then we will take dot get item, and we will take first zero indexed item in the first column. Then again we will use the same syntax. Here our second column name would be additional information. Then trim split, we are going to split the same column, and now we will take index 1 values, and then we will just display our data frame. It states okay, so I'll just need to rerun it. So it states that method object is not subscriptable. So just get item. Where are we going wrong? Brand, comma, trim, then split column. The column name is product only, comma, then separated by comma, get item. Okay, so it should be in round brackets. Same goes through here. Now let's try to run it. There should be 3 closing parentheses. So now we are expecting 2 additional columns. We can see one column with brand and then additional information. So now we can see that we have null values also here. Maybe I would like to delete the rows which has, or drop the rows which has null values. Drop NA. So earlier there were 397 rows and now we have 308 rows. Okay, and null rows are dropped. Okay, fine. Now let's move ahead and see our next data frame, which is this region. First, we will import, or sorry, we will fetch this table from silver region or silver layer. So maybe df region gold is equal to spark dot table silver schema catalog silver schema, and then the table name, which is region silver. So we don't have any kind of transformation to do it here, but let's say suppose we would like to change the cases of these columns. Maybe we will try to change it to the uppercase for all these 3 columns. So let's try to do that. Region, we will use with column function for the column name region, then comma, we will use our upper function, for the column name, which is region. So it needs to end here with the double inverted. Okay. Now we are going to use the same for country and then for the group. And then afterwards we are going to display it. Okay, that seems fine. Now let's move ahead and see our third table, which is reseller. Let's try to read that. I'll use the same syntax again. Reseller, then this would be reseller underscore silver. Okay, so this is our data frame. Here, what we will do, maybe let's say suppose we have city, province, and country, right? So we will make one additional column here with the column name full address, and in that full address we will have all these three values concatenated by comma. So let's try to do that. For this we are going to use with column function. Then our new column name would be full address. Then comma, and we will use concat underscore ws function. Then we are going to concat it by comma, and then we are just giving our three column names which we are going to concatenate. Okay, so this is how this syntax looks like. Then let's just try to display it. So this is how our data looks like now. This is our full address where it is using these three columns. Okay, so now this is fine. Now we will move ahead with our next table, which is sales table. Again, the syntax would be same. We will have one new data frame named as DF sales gold. Then we will use spark.table, and then catalog, schema, and our respective table name. So we have order date, product key, employee key, unit price, sales, and cost. There would be so many transformations that you can do on this table. So for the demo purpose, what I'll do, I'll calculate, I'll have one more column with profit slash loss where I'll do sales minus cost. And we'll see if that value is in negative, then that means it's loss. If it is in positive, that means it's profit. Okay. So let's try to do that. For this also, we will use with column function. Then our new column name would be profit slash loss. And we are going to use this on the columns, which we will round it on sales minus cost. And we will round that value till maybe one digit. So now let's try to see this new data frame. If you'll see here, we are getting negative and positive both the values accordingly. So this data frames looks fine now. Now let's move ahead for with our next data frame, which is salesperson. Let's try to read this data frame first. So our new data frame name would be df salesperson slash underscore gold park dot table, and then we are going to have catalog schema and our silver table, which is salesperson silver. Now let's see what we can do here. So yes, as we have decided earlier, we will try to split this column, which is UPN, and we will just fetch the value which is before at the rate as email domain. Okay, so we will have one more new column named as email domain, and in that we will have the information from this UPN column which is before at the rate. In this example, Brian Welker, then Michael Blith, such kind of information we will have that under new column which is email domain. So let's try to do it very quickly. So here also we will use with column function. In this, our new column name would be email domain, comma, and then we are going to split our existing column which is UPN at the rate, and we are going to take 0th index. So instead of get item, I can also do it as like square bracket and 0th index. And we are going to display it. We don't need full stop here, just 0th index. Okay. Now let's see if it is working fine or not. So we can see that we are getting email domain as expected for all the values. So now let's move ahead with our second last table, which is salesperson region. First, let's try to read that table. My new data frame name would be salesperson region underscore gold, comma spark dot table, and then we are going to read our table from the silver layer. Then we'll see what we can do here. So I think there is no need to change or do any kind of changes here because the information is pretty much simple and straightforward, and I don't think so we can do any kind of transformation for this. So let's keep this table as it is and now move ahead with our last table, which is target table. So df underscore, our new data frame name would be df targets gold, spark dot table, and then our table name would be targets underscore silver because we are pulling this information from silver schema. This table too, I don't think so. We need any kind of transformation here because information is very straightforward and clear. So we will keep this table too as it is. And now we are done with our all tables transformation. So we will try to save our tables, all these transform tables over here into gold schema. And in addition to that, we will try to save our information into our gold folder 2, which is here. Okay, so now let's try to do it very quickly. So for this too, we are going to define one function to avoid our repetitive work. So this function name would be write to gold catalog, for which we will pass data frame and table name. The format would be delta. The mode would be overwrite, and then save as table, where we will save our data into Adventure Works catalog. Into that we will prefer gold schema. In that gold schema we will give that respective table name, and then we will save that information or table values into that table. And then we will call this function 7 times to save our 7 data frames with the names as product gold, region gold, reseller gold, and so on. So right now we'll see this gold schema is empty. Now let's try to run this cell and we'll see if we are getting our expected tables in under our gold schema or not. Cell has been ran successfully. Now let's try to refresh this catalog and we'll check. So under this gold schema, now we can see we have our 7 tables in which we have this transformed data. Now we have saved our tables under this schema, and now we will try to save our this transformed files into our gold folder, which is into ADLS Gen2 account. Okay, so for that the code is again simple. Here we will give the path of our gold folder. The storage account name is ADLS Adventure Work. So the folder name is gold, then the storage account name dfs.core.windows.net, and then we will, the code is very simple. We are just repeating it for 7 times. So these are our data frame names, and for each data frame name we are going to write it into delta format, where the mode would be overwrite, and then we are going to save our files to our gold path, which is this one. And in this path or under this path, we will have 7 folders, namely like product gold, region gold, reseller gold, and so on. And under this or in this folders, we will save these files into delta format. Okay. So this is the code logic. Now let's try to run this cell. Now let's just check our gold folder. See, now we can see we have these 7 folders, and under these 7 folders we have our Parquet files along with their respective delta log. So now we have our data into gold folder and into gold table too. Okay. So first, now what we will do, we'll just try to check our type of table. Okay. So for that, what we will do, we will use SQL describe extended, then adventureworks dot gold schema, and then maybe for example for product gold we will try to check it. Just run this cell, and now it will give the information of that respective table. So if we'll come down, we can see here that the type of this table is managed table, but the location of this table is gold, and into gold we into ADLS adventure project we have gold folder, and that's the location because we have set this location explicitly for our work in the initial part, if you have seen. So in that case, like in the earlier part, if we would not have saved this location or set this location, then by default it will take the location which we have set for our Metastore. So if you remember, for our Metastore we have set the location of this folder, which is Metastore data. So if we would not have saved any one of this external location for this information or for these files to save, then it would have saved all that data under this Metastore data files. Okay. So as we have set it, we don't have any kind of information over here. Now let's say, suppose if you would like to use, or if you would like to use this existing managed gold tables which we have stored here under this gold schema. So we would like to maybe use those existing managed tables due to schema level locations, and but we still want to demonstrate how this Metastore folder is used to save some of our or to save the metadata of this data. Okay, for example, like schema details or the row counts. Okay, so for that, how we can utilize this Metastore folder, we will see that. So for that, what we can do, first we need to import one of our SQL function, which is from PySpark.sql.import, and we are going to import row. So now once we are done with that, we will set the path to our Unity catalog Metastore root folder. Okay, we already have set that. Maybe for example, let's say we will give variable name as Metastore path, and then in this path we will give this information, and this path will direct to this Metastore folder, which is into ADLS Gen2 account. So this is the base path where which basically which basically gets managed by Unity catalog. Okay, so we will try to save our custom metadata files into this Metastore data. Okay, so this is not Metastore, this is Metastore data. Okay, now we are done with this. We have assigned one variable for this path. Now we will list our existing gold layer tables into Unity catalog. So for that, what we will do, maybe I'll take one more variable named as gold tables. Into that, I'll give all the table names. Okay, so my table names are, first we will give catalog name, then gold schema, then product gold, sales gold, and then 7 table names. So these are the 7 table names. So we are listing our existing gold layer tables into Unity catalog. Okay, because these all 7 tables are fully qualified managed tables. So their actual data files are stored into this gold folder in here, but we are trying to list all these files, all these gold table into Metastore data. So let's try to implement for function for this. So the logic for this would be this one. So let's try to understand this logic. So firstly, we are going to loop through each of the table to save that respective schema and the row count in each of the table. So for that loop, we are going to use for loop on the tables which are present into this gold tables. Okay, so this one df underscore spark dot table, it will load the table into our Spark data frame, and then this logic table name is equal to table split. This logic, it will basically extract the simple table names. For example, over here product gold or region gold or reseller gold. So it will just extract those table names. So with this logic, for each and every table, it will read the data into data frame, and then it will extract the table names from its full name for naming or for storing that into metadata files. Okay, then the next logic is for it's for saving the schema info. So this logic, it will basically extract the each column name, data and its respective data type into a tuple. Okay, so once we have extracted this all information into tuple list, it will create a data frame. This second logic, it will create a data frame from the list with the columns. Okay, so it will create a data frame with the columns, namely as the first column would be of columns and then the second column would be of type. So it will create the data frame with this column and the type, and then this logic, this right logic, it will basically save the schema info as a delta table or folder into our Metastore data folder. So it will be named like maybe for example product gold schema. Okay, so then region gold schema. So such kind of information it will write into our Metastore data folder. So this logic is for saving the schema info. Then this next logic is to save the row count for each of the table. So it will basically first it will count the total number of rows into your in the table. Then it will create this data frame with the count and the table name. So for example, the table name is product gold. So in front of that, it will count how many rows are there into this product gold table. So such kind of information, it will be fetched with this logic, and as we know that we are using it into for loop, so it will be implemented for each of the table. And lastly, we have this df count write format delta. So it will save the count of or count info, we can say, as a delta table in our Metastore data, and then it will give you the quick way to track the table size over the time period. Okay, so this is the logic which we can implement to check how we can store our metadata into a folder which we have assigned to Unity catalog. Okay, so let's try to run this. So now we are getting this error. Okay, we are getting unauthorized error. So this is happening because here we can see that unauthorized exception, because this folder we have given it to the Unity catalog. That means that it is denying the permission for us to save anything into that folder. So if you remember when we were discussing some of the basics of Unity catalog, so one of that basic was data governance and giving or granting the access to particular people. So this clearly states that it has Unity catalog has the access, but we or I as an individual doesn't have the access to do any kind of changes into this Metastore data folder. So for this, we need to explicitly give this access for my email for my account, or for Gmail or Outlook, whichever account you are using to log into this Azure portal. So we need to give access to that. Okay. So for this, what we will do, we will use SQL syntax, and into that we will say grant read files, comma write files, comma create table on external location, which would be Metastore root location 2, and after this 2 I need to enter my email address. Now let's try to run this. Syntax error at read. I think we need to change this to these are not single inverted commas, these are these commas which you will get into that onto your keyboard before one. So that one we need to give it. Now it states that okay, it has granted the access. Now let's try to rerun this cell again. Now this logic has been run successfully. Now let's just try to check our folder. Now see, here we have gotten all these folders where we can see for each of the table we are having two folders. One folder is for the count, then the next one is for schema. One is count and then for the schema. So total we have gotten 14 folders over here to track the information. So this will be better, or it is useful for us maybe in the case of auditing or anything, or maybe if I have done any changes, then or if we have added some of the rows into some of the columns, and if I would like to check what was the previous situation, then in this situation or simply put into auditing, they can refer this Metastore data and they can check what was your earlier schema and what was the count from this folder or this information. So this is how we can utilize this Metastore data information too. So now in this case, as I have told you earlier, we have assigned our locations explicitly. That's why we have stored our data into our silver folder and gold folder. So if we would not have assigned this location, then by default for this managed tables, that information must have gotten saved into this Metastore data. So this is how this Metastore functions or we can utilize. Now let's try to connect these tables to our Power BI so that we can create some kind of dashboards and reports. So before this, what we will do, let's quickly try to understand what we have done till now. So just to recap everything, okay, we have seen what is Unity catalog. Then in this Unity catalog, let me write it. In this Unity catalog, we saw that this Unity catalog is nothing but a central metadata and a security layer inside our Databricks. And with this Unity catalog, we can manage who can see and access our delta tables and files in our data lake. Along with this, the third benefit or advantage is that it organizes the data into catalogs, schemas, and into tables. And this altogether provides us with the governance. So this is another benefit of using Unity Catalog. Then the fourth one is it controls the access to external storage securely. So as we know that we have used three external locations, right? So that accessing those three external locations and the data from those location, it makes it makes to use or to pull that data securely with from these external storages. And the last one is it lets you track your data lineage and metadata. And with this, it provides you with the compliance. So these are the main advantages of using Unity Catalog, and we have seen like how each one of them we can use it and implement it in our project. So now if we summarize all of our work, so if we'll see first when we created our external locations, what we did, we have used those ADLS Gen2 links into our into our Databricks as an external location, right? But with this or with use or using this external location or setting up these external locations with Unity Catalog, what happened? Unity Catalog manages this secured access to these locations. Okay, so these providing this secured access that will get managed by Unity Catalog. When we created our catalogs and schemas, Unity Catalog helped us to organize the tables or the information logically. So this logical organization that too has been provided by Unity catalog. When Then the third one is that when we wrote our data into delta tables, so while because of this returning of data into delta tables, Unity catalog gave us or helped us with the ACID transactions, and with that it helped us to provide fast querying. Then when we saved our data, specifically when we saved our metadata as delta tables into our Metastore data, Unity catalog helped us with the data discovery, auditing, and tracking of your data. And to access that Metastore data, if you remember, we were not able to access it, right? We needed to set our information, or we needed to set permissions for our Gmail or login address. So we can say that we need to manage user permissions too. And with this, how Unity catalog helps us, it controls who can access which data. For example, who can read that data, who can write to that data or do any kind of changes. And alternatively, it helps us with the data governance. So this is how this Unity catalog functions, and we have seen, or we have at least tried to see, how these information functions into our projects and how we can implement each one of them. So now let's move ahead and just check how we can connect our data to the Power BI. So for this, I have came to Marketplace. From here, Marketplace. Then here I'll search for Power BI Desktop, or I have this option here too. Then I'll try to connect it with the Power BI Desktop integration. Okay. Here the main step is you need to select the correct compute. So my compute which I have created, that cluster I'll select, and I'll download the connection file. So once I have downloaded that connection file, I'll click on that file so that my Power BI desktop will get open. Now it states that we are not signed into Power BI. So we have these three options: Databricks client credentials, personal access key, and Azure Active Directory. So amongst this, we are going to go opt for personal access token. Then come back to your Databricks. In here, go to select this account and then go to the settings. Into settings, we have this developer option under the user. Then we have this access tokens option. Click on manage, and then we will say generate new token. Okay. Then click on generate. So this token we are going to input there, and you need to make sure that you are copying this token because you will not be reopen it again. So we'll just copy it and then again go back to your Power BI, paste it here, and click on connect. So it will try to load all of your schemas and respective tables under those schemas. Now we can see that this is our catalog, adventure works. In that you can see we have all of our three schemas. Amongst this, we are going to opt for gold schema because this data is business ready data. So I'll select all of my 7 tables and then click on load. So once we get connected to this data, we will just see how we can create charts. Maybe we will create 1 or 2 charts. I'm not going to create the whole report. But in your case, if you'd like to go and create these dashboards and reports, please, I would urge you to go for that and create different charts so that you will get more hands-ons on the same. See, apply changes. It will take some time to load it. Let's wait for that. Okay, so now on the right hand side, we have visualizations, data. Under data, we have all the 7 tables. For example, if I'll select stacked bar chart, then maybe from the product gold, I'll select category on the y-axis, and then I'll have the count of category on the x-axis. Then format your visuals, and I'll turn on the data labels. This is how you can create the charts. Then maybe I'll opt for the second stacked column chart. For this, what we can do, maybe we'll go for reseller gold. On the x-axis, we will have countries, and then on the y-axis, we will have the count of the resellers. Again, we can change or we can format the visuals. We can turn on the data labels or ribbons. We can turn on the zoom sliders too if you would like to go for that. Any kind of changes on X and Y axis, you can do it from here. If you would like to change the title, go or come under general section and you can change the title too. So this is how you can create the charts, and you can represent your important information from all these 7 tables. And generally, once you do this, you need to represent these dashboards in front of the businesses so that business can take on these values and they will get to know like where is your exact position of your project and what changes they need to do if you are in profit, if your company is in profit or loss, and if it is in loss, then what kind of changes they need to do. So this whole procedure makes them easier to understand all of our data. So this is how this end-to-end ETL pipeline functions. This is it, and this wraps up our complete end-to-end Azure ETL project. In this project, we have seen how we can upload our data to on-premise SQL Server. Then we have seen how we can pull our data from on-premise to Azure SQL Server. Afterwards, we have seen how we can move our data from one Azure service to another Azure service using Azure Data Factory. So this process is called data ingestion process. So in this ADLS Gen2, we have created 3 layers of medallion architecture, which is bronze, silver, and gold. So after data ingestion, we have saved our raw data into bronze layer. Then the next step would be data cleaning and data transformation. So for these 2 steps, we have utilized Azure Databricks. In Azure Databricks, we have seen what is exactly Unity Catalog is and what's its object model. And we have tried to implement this object model into our project. For that, we have seen how we can create Metastore. Then we have seen how we can create credentials, external locations, catalogs, schemas, and then the tables. And once we are done with this, we have saved our data which is cleaned data into our silver layer. Afterwards, when we did data transformation, then we have saved that business ready data into gold layer. So along with saving these files which were into delta format, to our Medallion architecture, we have created tables too into our Azure Databricks. And these tables we have used to create the dashboards into Power BI. So this step was data visualization step, for which we have seen how we can connect our Azure Databricks to the Power BI, and then how we can pull our data, business ready data, which is into these tables, and with that how we can create dashboards and the reports to represent it in front of the businesses. So this is how our project looks like, and which we have seen. I know I still haven't covered each and every information into this one project because it's impossible to cover each and every concept into one project. So for this sake, I'm going to create more videos, or more, I'm going to structure more projects in which I'll try to keep, or I'll try to add up these new informations or the new topics, and with that we will try to create these ETL pipelines so that you will also gain knowledge and hands-ons on the same. So if you think that this video was helpful to you, or if you have learned something new, or it would have helped you to build your own data pipeline, then please, I would like to urge you to like this video, subscribe to my channel, and if possible, try to share it with your other data enthusiasts so that it will also help me to boost my channel. So till then, I'll say thank you so much and keep crunching the data. See you in the next video.